But Tali is not here, unfortunately.
I know that. Yeah. Okay, so people joining this, we are talking about array operations in Wolfram language, particularly heading into version 12.2. All right, so we're going to look at ArrayReduce first. And then I want to remind people that we had a variety of mechanisms here that we discussed last time. And I want to go through those mechanisms and make sure that we are on track to do things with them. Okay, so I'm going to remind everybody, I hope. All right, let's take a look at this. Okay, so there are different versions of this broadcasting type operation. I want to remind people of this, okay? Do people remember this?
Yeah. I mean, I think some people were not there, probably in PTO, so the reminder can be useful as well.
Okay, so there are three versions: headdress, infix, explicit. And I guess there's also this idea of level applied. Okay, so let's look first at level applied, because it's fairly straightforward, I think. It's just take this function, this is a headdress, take this function and apply it at level n. Right? Well, people understand this?
This is a very basic question. How is this different from map?
Because it is doing things like column application in an array. Okay, what do I mean by that? I think what I mean by that, it is doing, okay, so let's take a look here.
Well, I guess column application is useful, but I think level specs don't get you columns really.
Well, then maybe level applied isn't right, but as a, okay, so let's take a look here. We have array A34, for example, okay? Now, what we want to do is we want to apply this at level 2, and maybe level applied isn't the right term, but what we want this to do is an operation that is the equivalent, and I think Jose had identified this. It's a, it's a transpose, apply, transpose back type operation. Are we making sense?
Yeah, that's what.
Although is it apply? Sorry, go ahead.
Yeah, that's what ArrayReduce does, but that's the headdress version of this, right?
Yes, that's correct. So this is, hold on, let me just write this out here.
But also, by the way, it looks, at least in the ArrayReduce documentation, it looks like it's actually a map, not apply, because it's running mean of list of such and such instead of just mean of the numbers, which would be what apply does. Good
point. Except that we have a family of things like curry applied and so on, so we have to think about how that works. Well, we could call it level mapped. Okay, so let's understand here. So this is applying at a level. Okay, so there's the headdress form, and there is the explicit form. And the explicit form is array reduced. Is that correct?
Yes, yes.
Okay, so that's applying at a level. The other version is auto-replicating slash generalized listable, right? And for that, we also have 3 forms. Okay, there we have also an infix form. Okay, am I making sense?
Yeah, I mean, possibly. I'm not sure if we want to implement all versions for every operation.
I think we do in this case, right? Because this is the infix form we talked about at length, right? The infix form is an insertion at a certain level. And I think you've got design specs for that, right, Etienne?
For the insertion.
Yes. So it's this basically, right?
Yeah, which is, yeah.
Well, I'm not convinced that this makes sense, but
Have you looked at it in detail?
yes, and I don't think it makes sense.
Okay. Well,
And
what is your alternative suggestion? So I'm going to make a comment about it, okay? You are right that it has weird features. Just like listability has weird features. But listability, the weird features are definitely useful. This will have weird features. This isn't associative, for example. Plus isn't associative anymore with this, right?
right. Yeah, well, I'm not sure why Rob isn't here, but well, I guess
maybe we should get
Rob's out, but
okay.
uh,
Okay,
right.
well, anyway.
Maybe it would be better to do something like, in some languages like in Haskell, for example, for like combining arrays, they use plus plus as an infix. So I mean, maybe it would be safer to do something like that than to have another, to use just the normal plus, because that's kind of weird.
Well, it's an interesting idea that we could use, if we think there are two cases that are the most interesting,
like the two conventions, 1 and -1 about the level.
Yeah, right. Question mark. If there are primarily two relevant level conventions, and the operation we want is basically plus, and the main operation is plus, perhaps introduce another plus.
Well, actually, so that's an interesting idea, although that's not what I was saying. I was just saying that if part of Ichai's concern is overloading single plus, because single plus, and even stuff like associativity, it's like you'd kind of like to have that. And so if you're overloading it for this insertion thing, it might be kind of weird, because I can't think of any other places where we really overload plus for something like this.
Well, I agree, but so one question is it in fact the case that the only operation we care about insertion with is plus? Because if that's true, you might be absolutely right that the best thing to do. Go ahead.
Times, minus. I mean, all element-wise operation.
No, not all. Not all. There are many, many, many element-wise operations, right?
I mean,
look. The fact is that we can also imagine there's a headdress form, right? A level padded, if you want this for some obscure operation, right, you can say level padded circle plus whatever it is, right? You see what I'm saying?
Yeah. I mean,
But
plus
you don't want to do
definitely,
that,
times. I don't know.
that?
Maybe Jérôme and Matteo can give more examples.
So, which one?
I guess I should clarify that I suppose the two argument insertion where you are explicit so that the insertion evaluates first, basically, that makes sense. But the one argument form where it sort of
one argument form?
infers.
Sorry, what one argument form? What one argument form?
We were talking about it last week.
By the way, somebody has weird somebody has audio problem or audio.
Jérôme, can you mute?
Okay. In any case, all right. What was the one argument form you were talking about?
Where it sort of auto-magically guesses what it is.
What do you mean? There's a question of what level. Look, there's a question of where the scalar level is. Do you understand what I'm saying? Right? Remember that?
Yeah, we talked about that. I think this was not the big issue. But I think what Itai is referring to is insertion with only one argument, and that automatically find which level to insert. And this, I agree, doesn't make sense. I think we never advocated for that. Like the one argument would have a default, which is probably the opposite of what.
Yes,
Plus is
exactly.
doing.
That's the whole point. That's what we want to do. This thing here is the equivalent, is opposite to listability, to the listability default.
Right, and this is what I argue doesn't make sense.
Okay, well, I don't understand that. Okay, explain why.
Because, because...
No, why?
Well, if you let me finish a sentence,
Okay.
then maybe you'll hear why.
Please.
So, right, because, we have listable functions, we have functions which are not listable, but act listably, and maybe there are times when you don't want this to fire, like
okay, so
that.
So hold on. So the question is, should this work like, like for example, nothing on splice work? Okay, so nothing and splice are purely working inside particular functions, right? Am I making sense? So one possibility is that this construct only works with particular functions, like the arithmetic functions. Did you understand what I'm saying?
So the one argument form, or
the one argument form would only, well, I mean, it'd probably be a different name. I don't know how it would work there, but the basic idea would be it's only supported in the arithmetic operations, because you only care about the one argument form in the case where your function, okay, so if the function is explicitly given, right, e.g., i.e. f of x, y, rather than x plus y, then you might as well use a headdress. Does that make sense?
Agreed.
Well, except I don't know exactly how that then works, because then the whole point is you're wrapping, in this case, I see, this is saying pad everything until it gets to be consistent, right? That's what that means, i.e. pad all arguments to make them consistent.
I would say replicate. Like padding suggests that you have zeros or constant values, but...
Okay. Well, okay, so level replicated.
I guess it's padding, not in the sense that it's padding the array, but in the sense that it's padding, like if you run dimensions on it, it's padding the dimensions part.
Yeah, right. i.e. padding dimensions, though not padding elements, though replicating elements. Right? Okay, so this is for let's see, Freeman is asking, how does this deal with an arbitrary number of arguments? I think this is not a problem, because what this will do is any number of arguments, they'll all get replicated up to be, I mean, this probably would have, if we say level replicated, I don't really like the name. It's level padded, it's padding the levels, right? It would be circle plus, and then something about lev padded, and then something about which arguments are going to be padded, right? Would be the general form. And then this then goes and just does its thing. Now, an alternative might be to put a signal on the arguments to say this pads up, right? So the alternative is that you have the outer function and an argument is saying, I want to be padded up to be consistent throughout this function, so to speak, right? But then you, go ahead.
Sorry, I think this looks more usable because you are only.
No. No, you haven't been listening, right? The whole point is that's not going to work in general because many functions don't have that simple form. Only the arithmetic functions easily do that, right? So of course it's more usable for the arithmetic functions, right? But that's not the only case we're dealing with. Do you understand?
Yeah, okay. But it just can fail if our function is not supported. So
No. If you deal with something like nothing, for instance, okay, if I say A nothing B, right? That's a list, it works. If I say F A nothing B, it's dumb as a stone, it does nothing. Nothing does nothing, so to speak. Do you get it?
okay.
Same with splice, right? So that will be the pattern for this. Right, so then you can treat it symbolically, except in functions that happen to deal with it, but would be a well-defined set of functions.
By the way, Jerome has a bad connection, but he gave me a list of functions that we use in threading layer. I think so: times, subtract, divide, plus, power, and then we also have min, max, mod, and then the comparison
times,
function.
subtract. Say it again.
So times, subtract, divide, plus. Okay, the classic simple arithmetic thing, and then power.
Well, min, max, but you know these are not very obvious what to do with them, because what you're saying is you're saying, for example, that you want to be able to do something like this. You know, this thing here, right? You want to be able to say,
yeah, I'm not sure if it's this fit
no.
with our
So in this case, listability is what you want to be able to do is something like this. You want to be able to say, you know, dot power, whatever it is, and then you want to be able to say ABC, right? Is that right? Or do you want to? Is it the other way around? No, in standard listability, right? You can do this.
AB.
Right, that works. But what you want to be able to do is this case as well.
Exactly.
Right. Okay.
You can also add all logical and comparison operators to that list,
which are not currently listable.
Which aren't listable, right? So these are non-listable.
But it's something that would be nice to have listable.
We have the vector versions of less and greater.
Yeah, right. Which so in that case, vector less of what is it? How does it work? 6, 7, 1, 1, 8, for example. No, what is that supposed to be?
Okay, but this is one result.
No. Wait a minute. How is this supposed to work?
You give it a list of things, right? So that would have been a one argument, because the second argument is a comparison.
Okay, so this is doing something completely different.
No, it's not.
Yes, it is. It's asking you whether any of these things, which vector is, you know, whether any of these is less, isn't it?
Yeah, I think we're talking about different things. Yeah, this is just comparing two vectors, whereas the listability
what you want is something
element.
Where you get true, false, you know, a list true, false for each element that is, you know, and where you can say bool of that and so on, right?
Exactly. When you get an array, a sort of array mask type thing, which is something we use, yeah.
Okay. Whoever's got bad connection should put themselves on mute, please. Okay. In any case, all right. So one of the ideas here is, I mean, this is clearly what the kind of thing we want, but it has issues, as listability has, with associativity and other such things. So, you know, a very convenient thing would be if there was some kind of operator modifying, you know, notation that we could use. But I think that still doesn't help us, because if we've got a 3-argument plus, and one of those arguments, one of those is the, I mean, what would happen? Let's imagine that we had something like, if we say one thing, A plus, well, here, I need to write it out more explicitly, but I mean, something like this, and then we say, this is our dot plus or whatever it is, and then this, which by the way isn't an allowable syntax, and then we have another one here, which is an ordinary plus. So I don't know, insertion AB, for example. I mean, in other words, it's very unclear what this means. In other words, it has to look around. No, actually, that's a bad example here. Let's just do ABC here. See what I'm saying? So it's not clear which way round you do this, and it matters. Is this making sense to people?
Yes.
So, the question is, for example, if you had 2 insertions in here, what would it do? In other words, in this case here, I mean, it gets quite messy, because in this case, let's say we had another insertion of the same form, right? Presumably, that just is the equivalent of 1, 2, 3 plus ABC inside that insertion. It's like you collect the insertions first.
And yeah.
But it's not obvious what happens if that insertion has, for example, this in it, which would require another level of replication. Actually, I'm not even sure if this is conformable at all.
That's another topic, by the way. That would be nice to have not just new level inserted, but also level of dimension 1, which you have here, that are kind of promoted to dimension that is needed.
Well, explain that to me. I mean, so isn't
that 3 times 1, right? What you did is a array 3 times 1.
Yeah.
And if you look at the array on the left, which is
2 times 3.
Oh yeah, so 2 times 3. Oh no, this one won't be conformable. Okay. But let's say you have 3 times 1, and we had a 3 times 2. Then you could promote the 1 to be a 2. There's no new level inserted, but you just duplicated, and this works as well. And
I don't quite understand that, but look, so I mean, what you're saying is this level padded thing, we probably should work out how that works, right? Because that's the general, that's the more controlled case of this. Getting an infix form is derivative on that. Does that make sense?
I would agree with that statement.
So let's go figure out how this thing should work. Now, the explicit version of this, that's array replicate, as opposed to the explicit form here, which is array reduce. Okay, do we understand how array replicate would work? That basically takes an array replicate simply takes an array and gives the final dimensions, and then it has to probably say where it inserts the replications. Is that true, or does it know that?
It does need to know, and I think we came up with some syntax for this last time.
Okay, well here we've got before dims and after dims. Here we go. Yes.
If you scroll down, you probably see them.
Yeah, I think we actually had a.
Oh yeah, here you go. Yeah, you have a list of rules somewhere, right? Replicated array. Yeah. Insert after. You have a little comment.
Okay, so fine. So could we get a mock-up of replicated array, please? Could somebody make that? Right.
Okay, that would be nice to specify somebody, because I mean, I'm happy to do some things, but it's not our core expertise, let's say.
Well, we've got the wrong people in this meeting then. I mean, I think you guys should make a version of this.
Okay.
And then we can
I mean,
figure
I can do a
out.
top-level version, you know?
Yeah, exactly.
Yeah.
And if it's really going to be burnt into some low-level code, maybe that's something we can use modern compiler technology for. Maybe Zbigniew can work on it. But let's first of all get the design handle, which is not very difficult, you know, to see in top-level code.
Mm-hmm.
Okay, so this is, let's see, what the syntax here would be before dims and after dims, right? So that would be that form. And then there's the before dims, after dims. Okay, and that's the thing that once it's been done this way, after replication, pure listability should work. Is that a true statement?
Right.
Is this always true?
Well,
I
if
think
you do
this
your
is
job
always
correctly, yes.
Yeah, I think it is always true because listability goes from the top. This is an advantage of listability going from the top. Do you understand what I'm saying? Do you understand what I'm saying?
I don't understand what you mean. Why listability?
Okay, what I mean by that is listability, whereas the alternative convention for insertion looks at the lowest level, like this insertion 1, 2, 3 would go in and insert in the lowest level, listability starts from the top. So long as these things are conformant at the top, listability should work. Right? And ArrayReplicate will make them conformant at the top. They may have lower level pieces that are not conformant, but that's not relevant.
It will evaluate to just an array, right? ArrayReplicate. So then all the
Yes.
rules for regular arrays work. So
I know that, but what's not obvious is that if you've got let's say you've got something which you were going to do with insertion, right? The whole point is you could explicitly ArrayReplicate. Insertion, okay, if insertion knew its environment, insertion is equivalent to ArrayReplicate. Do you understand what I'm saying? Insertion is a shortcut where you're not specifying the environment inside the insertion.
Yeah.
Yes.
Right? Okay, so what I'm claiming is that were you to replace insertion with an explicit ArrayReplicate, that then the operations plus times whatever they are would work correctly with respect to just by listability. Yeah, that's my claimed theorem, and that should be checked. Do people understand what I'm claiming?
I believe that to be true.
Okay. Now, obviously, there are some exceptions like the less greater thing because they aren't listable. Am I making sense? I mean, it's not obvious to me that we should study the question of making less and greater listable. I mean, right now, it's just an error.
Actually, it doesn't evaluate, I think.
Yeah, I know. Right. So,
I think there have been a number of times when I've wanted to use them listably.
yeah, I mean, I think that probably should evaluate. I mean, let's ask. Can somebody send out a piece of mail generally?
I think the problem here would be equal. So these functions are tightly related to equal.
I see. Yeah, that clearly cannot be listable.
Although maybe, I mean, that's another thing though, where it would be nice to have, like, there are times when you do want it to be listable and there are times when you don't, right? So,
Right.
I mean, I'm trying to think if there's some existing thing that kind of does this, but it might be nice if there was kind of a headdress that you could put, that basically just says, make this listable. I mean, of course you can use function, but it's a little bit
well, okay. So that
direct.
is the question of a question mark.
There's thread.
Yeah, map thread.
Yeah, there's thread. Yes.
Okay, but does thread work if I say, I don't think
But not necessarily for higher levels, right?
But also, what about okay, so this would be something where you would say listably equal A, B, C, D.
But so now this though, right, because you could just do listably, but another version you could do would be at level X, which is kind of similar to what we were talking about before.
Yes.
Which seems a bit like map thread if you could give it like a level spec.
Right. So this is similar to level applied equal, comma 1, A, B, C, D. So that's suggesting that the default case.
Actually,
yeah.
Go ahead. Well, I mean, so map thread actually, I just looked at map thread does actually take a level spec, which basically does this. So it's, you know, do you understand? So it's like map thread of, yeah.
I mean, but that because it's not a headdress form, it's map thread into map thread of equal onto A, B, C, D at level, well, let's just do an F here. Okay, that's that. Right. But map thread, does map thread have an operator form?
No, I don't think so.
Yeah.
Oh, it did.
Yeah.
Okay.
But of course, it can't have a
level spec. Right. Okay.
In relation to equations, we designed apply sides and things like that. So that was our way to avoid automatic threadability in equations.
Yeah, you're saying something like apply sides F of, A plus B equals C is that. Which I think is useful. I mean, that's more of an elementary math play, but definitely useful there. Okay, let's go back again to ArrayReduce. So, I mean, I think we've got, yeah, all right. So, okay, so I'm still trying to understand here. Okay, we've got array replicate. All right, so the general, I'm just trying to understand this. The general form here is array replicate. We think we have a, I'm not sure if the name is quite right, but
right, and last time we were discussing sort of a more general syntax with a list of rules.
Absolutely, yes, absolutely, that's correct. So this is, this left, right, insert after, and so on.
Right.
Okay, so I think we've got array replicate ready to do a trial implementation. Okay. I think we even had here, yeah, so we even had a proposed syntax here, right? I mean, a proposed version. Oh, we also had it possibly called pad dimensions.
But so, sorry, is that, or I guess maybe the second, okay, so I'm not sure that this usage is unambiguous though, right? Because if I have something of length 3 and I say, array replicate, make the final dimensions 3, 3, 3, 3, 3, 3, 3.
Right, so this is why we turned into last time, this top, bottom, 1, -1, et cetera, et cetera, et cetera. This is specifying which, this is the correct form, okay? And we need to just get an implementation of this so we know what we're talking about here. Okay, we had nailed down something pretty good here, which basically inserts into the levels. This works just like insert works, but it makes these levels, it pads out those levels, if that makes sense. So in other words, in the dimensions list, what this is doing is it's saying at position 1 in the dimensions list, now have 3, 5 at position 1 in the dimensions list. Makes sense?
Yeah.
Okay. So now let's go back to what we originally. Now I think I'm ready to do ArrayReduce. Okay, so let's take a look at ArrayReduce here. Which is different from level applied, which I claim is going to be, or level mapped, which is, I claim, the a very useful general thing. Okay, so this is the explicit form of what will otherwise become a headdress of something like level applied. Right, guys?
Yep.
Okay.
So again, I claim that the first usage is just map.
Reduces level n. No, it isn't, because
No.
because what's happening here is, like subset map, this is
Well, reduces doesn't mean anything in our language, so.
Yeah, I mean, look at the example below. That's just doing map at level 2.
In this case, yes.
Level 1.
Or level 1 in this case, actually. Yeah.
Level 1, exactly.
oh yeah, that's not useful. Yeah.
So yes, so what it is actually, the first usage is a transpose to put level n to be the last level, and then a map at level -2.
Okay, so you're saying the first usage is basically that, if you have an array A, it's transpose of map of transpose of A. That's the first usage.
There's not two transpose, just one transpose to put the.
Oh, there are two. Actually, not there, because you've got to put it back again.
No. Well, not in this case. Yeah, it's true that there isn't necessarily a transpose here.
I mean, it depends what we mean by transpose, but that's putting the level n at level -1 with the last, and then a map at level -2, and you have your reduction for the first case. And then for the other usage, it's more of a flatten.
Okay, let's try to understand these usages and then try to understand the headdress form. The headdress form, we have an array. Let's say we want to say, let's take this example here, okay? And let's look at the headdress form of this. And so we want to say level applied of mean onto this, okay? And what does that mean? That means that what we want to do is take, let's see, mean normally. What does mean do ordinarily?
It would work at level 1, right? So you'd get the mean of.
So mean will work at level 0, right? It will take the whole expression.
Well,
so that's why
right, but
you have to map it at level 1, and you get, as Christopher was saying, the equivalent of the ArrayReduce at level 2.
Right. Actually, mean has a convenient feature that it just does what you want here. It does the column-wise mean.
Yeah, which is very useful in
right.
Like for standardization, we just do a data set, and that's
right. Okay. So mean is a bad example. Mean happens to work column-wise by default.
Well, I mean, in this case, you can interpret it as being column-wise, right? But really, it's just adding the elements and dividing by n.
Oh, I see what you're saying. Okay. But actually, it's just adding the top-level elements using listability.
Yep.
Right. Okay. So that's a pure coincidence of the fact that, plus listability, mean, et cetera, et cetera, et cetera. So the more common case is you say level applied of this, and what it's doing is it's going to apply to columns, and then that's.
I mean, I'm
not
sure there would be a no argument. I'm not. I mean, why would it be column by default? I don't think there's.
Well, it might be level 2 by default. Let's not worry about that for a second.
Yeah. Okay.
I mean, I think it would probably be level 2, but column level 2 by default. But
level
here,
-1. Yeah.
I think level 2, but I'm not sure. But anyway, okay. So let's say it's this. Okay, so what that means is this is going to say, this is going to turn into f of 16 list 1611. No, a single level of list. F of
No, actually, it's the opposite. I mean, check the example. I think it's the opposite. It's
which example?
Can you look on the ArrayReduce documentation? Yeah, so that's the opposite.
Really bad case, because do we have an implementation here? Can I actually run this?
Yeah, if you do if you do numeric array utilities backtick ArrayReduce, like I removed the
Okay.
And you probably have to do a get general utilities.
Okay, hold on.
Sorry.
What do you want me to do? Just tell me what to do.
Get numeric array utilities. It's a bit of a mouthful, but utilities, yeah, and exactly. And then you can actually, with that, you should be able to use ArrayReduce, but you don't, which means you have a too old version.
I'm not running 12.2 here. I don't think I'm running 12.2 here. So let me.
Oh, that's why.
12.2 head branch.
Yeah.
Why is the startup so slow? Can somebody, Devin, can you report this again?
Yes, yeah.
Okay. All right, so then I run this. Okay, now you say, I can say ArrayReduce,
and it should work.
F of, I don't know whether this is a nice object. Let me, just so I'm not confused about what this actually is. Let's do that. And let's now say ArrayReduce F. And now do I need another argument or not?
Yes, you need to say the axis that you will reduce on.
Okay. Okay, that's just map.
In that case, yes.
Okay. I don't think this is the right way around.
It is. That takes.
Okay, explain it. Explain. So the axis. This is.
I think it's squishing it in that axis as
Exactly.
opposed to what map does, which is kind of the opposite.
I don't think it's the right way to say it. I think we should say at what level it is going to do its operation.
I mean, when
the second one is not reproducible with labels, sorry. It's some sort of subset map operation.
Right. So this is the thing about transposing it. Right. So it's transposing at level, you know, it's transposing level 1 in this case to be level -1, and then it's mapping.
Exactly. At level -2. So that's why it's kind of reducing this.
I don't think this is going to be understandable. I think people are going to think of this as doing the operation. Look, this is the equivalent of taking this thing, okay, and saying, you know, and doing this and saying all comma 1, for example, right? And then doing, so that's, in other words, it's doing its thing, and maybe ArrayReduce isn't the right name, but it's doing its thing at level 2. It's cycling over level 2, well, right? It's alling.
I mean, this is, I think, what the point of the word reduce is that you're basically, you're getting rid of level 1.
I think that's
which level are you getting rid of?
I see. Which, wow.
This is a combination of map and transpose, right?
Yeah.
But another way to say it is that what we're doing is we're saying we're going over all the indices. This is allifying every index other than Well, this one is saying which indices to allify in some sense. Is that correct? And you're going to reconstruct an object from the other indices that haven't been reduced out.
I'd like to point out that quotes allifying is the same as transposing.
Yeah.
All comma one is just a part one in the transpose. Yeah, sorry.
I think with a rank 2 we can get confused. There's only 2 levels. But I say a rank 3, it's pretty nice. So it's really removing the level that you indicate. If you have a matrix of size, an array of size 3 by 5 by 2, if you say ArrayReduce at level 2, it will remove the 5.
Okay, so 3 by 5 by 2, for example.
Exactly, yeah. If you have this, if you do ArrayReduce of, I don't know, total, doesn't matter. To be simpler, total, and then level 2, the dimension is going to be 3 times 2, because the 5 is gone.
What the hell happened there?
I'll check the dimension.
But what did it do with its totals?
I don't know what happened here.
Well, let's take
can
a
you
look.
use F? Right.
Yeah, that's not right.
I don't know. Check the dimension.
It has 3 levels, so it cannot be what you say.
Yeah.
It just transposed.
Yeah.
I think this is just an implementation bug.
Something wrong, which is weird. Maybe it's okay. Anyway, maybe it's in the process of speeding up ArrayReduce. Something happened. That's weird.
Okay. Well, okay. So that needs to be fixed. But okay. So you've got an example here.
Yeah. Yeah. Exactly. Like this one. Actually, the same example. That's weird.
Okay. Hold on. So this is saying compute the standard deviation over the second axis. Is that really over the second axis when you're reducing? What on earth does that mean?
I think the problem here is that the standard deviation is like mean. It does more things with vectors. It has additional.
So it's a bad example. So can we please not use mean standard deviation in the examples here?
But that's the same. I think if you put F, it works. I don't know why it doesn't work on your own. That's weird.
Okay.
There's something wrong going on. But that's what it should do for any of any function.
So hold on. So you're saying the array there. I can't do these. If I'm supposed to do this arithmetic in my head, I can't do it. If it was A's and B's, I might be able to see which one went from which one. What is this doing now? So this is taking each pair.
So I think the way to understand this is first transpose the level you are interested in to the bottom, and then map over it.
Yeah, that's definitely one way, and that's how it's implemented. Otherwise, check the dimension of the array, 3, 5, 2. When I say reduce on axis 2, it means construct 3 by 2 vector of length 5 and apply F on these vectors of length 5. Like it's define all the vectors to which the F is going to be applied.
Right. I would think an alternative name for this would be level apply or something. And then that, if this was called, okay, let me just copy these things in there just so we remember what's going on. If this was called, possibly, or level apply. Now I understand this map thing is an issue, but if we had level apply and level applied, a level applied is the headdress form, and level apply is the explicit form.
Well, but I think, right, these are two different things, right? ArrayReduce is a unary operation, whereas the level applied is for...
No, that's not correct. This is the headdress form of this. This is a completely different thing from the insertion stuff we were talking about. That was level replicated.
Oh, okay, yes, sorry, I got my names confused.
Right, so this would be level applied. So if we said, to me, it would make sense, but maybe it doesn't work. If we said level applied, and maybe you're telling me that this isn't the way it can work, level applied of F, 2 means do column-wise application. Can that be made to work? and then level apply. Level 2 means apply to level 2, apply this operation to the level 2 things. I mean, that seems understandable to me.
Yeah, for a matrix, let's see for maybe you're right, but let's see for an array of rank 3.
Yes.
So
Okay,
in the case 3 by 5 by 2, what would that do?
I think that this thing, what it would do is it would treat it as a triple of 5 by 2 objects, and then it would apply f onto the 5 by 2 objects.
Exactly. So it's not on a vector. So the whole thing of this business of reduction, you have a function that you give a list of scalars, a vector, and it computes a number from that.
No, I understand.
Total,
but
mean, standard deviation.
I understand. I understand. That's one thing you might want to do, but that requires going down. That's a different thing.
I know, but his level applied is a different thing. It's kind of like you're going to do f on arrays, not f on a vector.
Okay, so the question here is, does in ArrayReduce of f comma array, does f or lev spec, does f ultimately get applied to subarrays or to lists of scalars? Okay, that's really the question of the default. And that's similar to this insertion business, where there are two different ways of doing it, right? One is to go down from the bottom, and the other is to go, up from the bottom or down from the top. What traditional listability does is go down from the top. Am I making sense? Right?
This reminds me a lot of the situation with flatten, in which one can think of flattening one level, and then, but the notation allows flattening many levels at the same time. And also in the sense that flatten internally contains a transpose. Well, here, in my opinion, the key operation here is transpose.
Mm-hmm. Yes.
So yeah, it's a situation similar to that, and same level of complication. People having problems understanding what flatten does in the general case.
Right. So Sander is commenting,
and the fact that it's different. Sorry, just saying the fact that it's different from map and all these other things is its power. Is that you can do some operation more simply than
but you can't achieve column-wise operations with map.
You cannot. So that's another thing. Yeah, having
right. So one of the objectives here is to make sure that column-wise operations are easy to do. So maybe there should be different generalizations.
Yeah, maybe there should be a column map and a column apply or something.
Well, we've thought about that. We've thought about that, but I mean, I think, so that's.
I mean, that would just be the transposive map of transpose. Because that's not what this is. It's turning out.
Yeah.
I mean, you could generalize it more about, if you have a tensor, if you want to apply it at an even deeper level, but I'm not sure. I think even just doing columns is a useful, is a useful thing.
Yes. Okay, so comment from Sandra on our live stream. If you have a 5-dimensional thing, it is, let's see, if you give, so he's commenting that, I think this is supporting your idea, Etienne, that ArrayReduce of level n removes the nth index, and that's what you're proposing.
Exactly. Well, the map is kind of specifying the level that we keep, or the equivalent of map, and this one is specifying the level that you remove.
Okay, I need to go to a different meeting in a moment here, but
sorry, one comment. Notice that the removal is not performed by ArrayReduce itself. It's F, which is responsible for removing.
True.
So that's important thing, because you could have also mapping a function that removes things. It will work.
So Stephen, I've just put in chat a simple function, which I believe is what Etienne is claiming ArrayReduce does, at least for the single level case. And so then you can apply this to your array of 352, and Etienne can tell us if that's what he really means.
Yeah. Yeah, I think that's
Okay,
it.
so this 352 here. So this is simple reduce 352, whoops, F 352, comma 2.
Although actually I'm not sure it's this, anyway. Because you're switching n and rank, and I think it's not a switch, like n should go at the end, but rank should stay.
Well, so this is now a 3x2 thing that had the F. So I'm very confused here. Why is this not map at level 2 of F?
Map at level 2 will keep the 5.
Right. The point is that the level 2.
Does it apply at level 2? Why does it not apply at level 2?
Because you're keeping the 2 as well, right? So you'd end up with something of length 3, because you'd wrap every 5x2 matrix in an F. This is not doing that.
So this is a combination.
Again, what it's doing is it's basically it's another weird way of thinking about it, because you're talking about the allifying, right? It's like array part. You map over. Okay, you say array part all comma hash equals f of array part all comma hash, and you're just mapping over all the indices, and you're changing the number of alls, right? That's what this is doing.
Yeah, so it's basically the same thing, but the transpose is, like in that case, it was working, but the true transpose is this one. It's you're not switching the last one and n. You're just putting the n at the end.
All right, look, let's do the following, okay? We also want, so do we understand the headdress form of this thing? I think it's rather straightforward. I think it's basically just I think it's just an argument switcheroo on this. And it's possible even that's just the operator form of this.
I think so. The only thing I'm worried here is that we keep talking about levels, while here this is all shifted by 1. What Etienne calls axis 1 is our level 0, etc. So we should be careful with.
Okay, well, let's see. Levels versus axes, question mark, shifted by 1. I have to go to a different meeting about chemistry, which actually is also going to be live streamed. But we really need to, I think we're getting closer here. I would really like to follow this up, perhaps later this week, before we've all forgotten how this works. There was a question here on the live stream about tensor notation, and I'm just wondering, can we write out what this is doing in indicial tensor notation, so to speak? Or does it not have an analogous operation there?
I think I can do that. I have to think a bit about it, but I think it's
so. Obviously, the transposition part you can, because that's just super simple.
Right.
Sorry, you can. You just T mu nu goes to T nu mu or something.
Right.
Right. But I don't know about this reduction. How do you do reduction of a tensor, of an axis of a tensor, so to speak?
It's mapping. So you just have to wrap f around the tensor once it has been transposed.
Yeah, but then how do you transpose back again? I mean, in standard tensor notation, I'm talking about.
And that's the key property we were referring to before, that the function f is supposed to do something. It's supposed to convert vectors into scalars. If it does something else, this is going to break. So I think we have to separate.
Is it going to break? I mean, is this going to break, or is it going to? It's not going to give the. Okay, so this form.
So imagine that it converts vectors to vectors, like subset.
No, I understand. Then this would not be 3-2 anymore. It will be something different. This form requires that f maps vectors to scalars.
Exactly.
Well, I think in order to get the dimensions to be exactly what you say, but
Right. It's not clear that that's what you need.
yeah.
Yeah,
But
actually,
I
we
can imagine
generalize
maybe
it.
there would be
The dimension
where you want-
identities.
Yeah, actually, we generalize it. So, I mean, we had this discussion before, right? And we ended up, you know, the other usage lines where you have, you can also, instead of constructing vectors, you can also construct arrays. So it's a lot. I mean, the version just after are classic, but the last one, that's kind of the one Alf came up with, and with the help of Julio had a good idea to make that simpler. Anyway, so it's basically the same spec as flatten, and this defines a bunch of arrays basically. So the spec before defined a bunch of vectors to which you apply f. This defines a bunch of arrays that you apply f to.
Right.
Right. So that's a general case. Arrays to arrays, and then it's flatten. It's a generality of flatten.
Yeah, it's same spec as flatten.
Okay, let's continue within a few days here, and let's see if we can nail this down. I think we're getting pretty close. Okay, people on the live stream, thank you for your comments, but we are now going to a chemistry discussion, which will also be live streamed. Okay,